Hey everybody, this is Larry. This is day 8 of the Leetcode May Challenge. Let's get right to it. First problem of the day 1. Check if it's a straight line. You're given an array coordinates I equals xy, where xy represent the coordinate of a point. Check if these points make a straight line an xy point. Okay. So this is a computational geometry problem. Also, hit the like button, hit the subscribe button. Let me know how you did on this problem because it seems like it would be a little tricky. And there are a number of ways to do it because it is a little bit geometry-y, but it's more geometry-y as well. So yeah. So I think the first thing to notice is that all these points have to make a straight line. So if any point that's not on the straight line, then you can already return a force. And the way to do that, let's see. And the way you could do that is just, get the slope of any 2 points and then check all the other points. That's how I would do it. There are a couple of edge cases. The main one being a vertical line. But let's implement this and then we'll special case the vertical line. I think that's what I'm going to do. Okay, let's get right to it. So let's just say xy is equal to the first coordinates. That's also, I'm just double checking that we have at least n is equal to 2. Otherwise, we have to just do some gating. But otherwise, let's just call this ax, ay, and then bx, by in coordinates. And at this point, we can actually, there are a couple of ways to kind of do it. And I think I'm going to do it that way then, actually. Just start from the second one, and then let's just do dx dy is equal to the delta between the first x minus the first, the coordinates of x, and then also the y coordinates portion of this. Basically the difference between the first 2 elements. And then now we can just check, naming variables is a little bit tricky on this one. But yeah, so now let's just do current dx and current dy kind of is what I'm trying to go for. And then current dx is equal to coordinates of, oops, that's not right. Actually, current x and current y, and then we have current dx, current dy is your coordinates, or actually cx minus the first coordinates, and then the y version of it. And then now we have to just check if dx over dy is equal to the current dx over cdy, and if this is the case, if this is not the case, then we return false. Oops, forgot the entire word. And then otherwise just return true. So I'm not going to submit this quite yet because, we didn't deal with the vertical line. But also, this equation obviously deals with floating points. So to avoid that, let's just do some manipulation and then basically move the things on the side. And now now we can at least test it. And again, this is a true false answer, so I would be a lot careful, even if this is correct. So now let's test the base case of 2 points, and also, as we said, horizontal line and horizontal lines and straight lines, just to see. I don't think straight lines would work because actually, we'll see. Because we don't do any divide by 0 at least, so that's at least a good sign. Yeah, we can make it anywhere, I suppose. And then maybe a combination of those two, just for kicks. Yeah, so it looks good. Do I have to think about vertical line? Because the way that we did it, if it is a vertical line, then the dx is going to be 0, and then the other dx has to be 0. But yeah. Okay, let's submit it just to see. With these things, I'm always a little bit not confident because these are a little tricky, but it seems to be okay and accepted on first try. Overall, I mean, I want to say that I haven't seen something like this on an interview, but this is really basic geometry, and I would kind of, you know, I mean, it's basic enough that like you should probably study a little bit for an interview. For computer programming, this is relatively basic. I mean, I don't know if this is a easy or medium, but I would lean toward like a maybe slightly harder easy or a really easy medium. Um, but yeah, and the algorithm here is of n running time because we look at each coordinate once, and we do constant time for each one. And for space, it is just all of one because we just keep like 4 or 5 variables or something like that, 6 variables. So yeah, so the trick about these things is kind of try to figure out, yeah, just how to like what is it about this problem that you keep from point to point, and that's my logic on this problem. Cool. That's what I have for this problem. Let me know how you feel about this problem in general and geometry problems in general. I always have tricky, like it always feels a little tricky, and I always not that confident about it, to be honest. And that's why even when I submitted, I was like, maybe it's right, maybe it's not. But yeah, hit the like button, hit the subscribe button. Let me know how you did. Bye bye.